Alright, here we go. Weightlifters, they put that dust on their hands before they lift weights, right? Runners, they stretch and they warm up before they run. What do we do, mathematicians, before we start mathematizing? Well, of course, we play some jams. Goes like something like this. Get your mind in the right mood. Oh yeah. Alright, so today we're doing integration by parts. Now what in the world is this? The reason we're doing this is because we have problems simple, such as that one, which appear to be very naive, and you try all the things that we had before, like all sorts of U-subs, and it's not a basic one, and none of the things that we had before seem to work. So we have this brand new idea called by parts, which at the heart of it is just a method for integrating. I'll explain where it comes from. It starts from the product rule, and I'll remind you what the product rule says. It says something like this: if you've got the differential of a product like xy, and suppose you wanted to take the derivative of it, well, you'd probably do something like this: the derivative of the first times the second plus the other way around, first times the derivative of the second. Or using the differentials, it would look something like this: differential of xy is equal to y times the differential of x plus x times the differential of y. You've all done that, right? If you haven't done that, you're watching the wrong video. You should be watching some other video came way before this one. Alright, this works for anything. It works for functions f times g in general. Suppose they're differentiable, whatever. They're nice functions. You got f times the differential of g plus g times the differential of f. Today we apply this amazing idea to special letters u and v. Nothing special about u and v, it's just tradition. Out of tradition, people have used u, v. And so it goes like this: u times the differential of v plus v times the differential of u. And then something amazing happens when you try to undo this step here, the differential of the product step. To try to undo it would mean specifically to try to take the antiderivative of that side. That would give the antiderivative of that. That would give the antiderivative of that. See how I did that? I'll redo it for you, like that, like that, like that. See? Like this. Take the antiderivative on all sides, and what that would do is, on this little piece, the antiderivative and the derivative would undo each other, and you would get that the antiderivative of the differential of uv, well, that of course would be just uv. This would be the integral of u dv, and this would be the integral of v du. Now suppose I solve for this piece all by itself, meaning this one I move it over to the other side. That would give me that uv minus integral of v du. Well, that would be the integral of u dv, right? Just by moving this one over to the other side, you get that. And then let's just keep things a little separate here. Suppose you switch this around and just say, hey, I'm going to call this is going to be my left side now, the integral of u dv, and that will be my right side, uv minus integral of v du. Well, if you did that, that would become, of course, the most famous statement here from the integration by parts. It says that the antiderivative of a function u times the differential of another function is the same thing as the u times the v minus integral of v times the differential of the u function. And that turns out to be amazingly powerful for so many problems where many of the other techniques fail, that it becomes one of the favorite ones for calculus students, or for anybody who's doing integrals. So good, maybe we should circle it, yeah, or ellipse it. We shall ellipse it, and then we will call it the integration by parts. There, let's try this again. Yeah, I'm gonna get better at using this software. Don't worry. And I can even make it red. Watch this. All I did was add a little red to it. There it is, our famous integration by parts. Voila. The question is, how is this helpful at all? Well, let's watch the next video.